The object of this video is to demonstrate the process of anodizing aluminum for any home machinists or others who make projects from aluminum on the lathe or milling machine and would like to anodize them. The benefit of anodizing, of course, being the hard surface and the ability to color your workpiece nearly any color that you'd like. These three pieces here are an example of a finished anodize on what will be the host for a laser project. Here's an overview of a simple and cheap, effective anodizing setup that can be simply and quickly built. On the very left, I have a rewound microwave oven transformer that's rewound to produce 15 AC volts. To its right is a rectifier block on a heatsink. This turns the AC from the transformer into the DC voltage that's required for anodizing. The gray cylindrical object in front of the transformer and rectifier assembly is a power resistor. This is there to reduce the current drawn by the process so that we don't burn our part with excessive current flow as opposed to just anodizing it. You can substitute a car battery charger, 12-volt car battery charger, as your power supply. I've used a 12-volt battery charger and it works just fine for anodizing small parts. So go right ahead and use a car battery charger if you have one lying around. I had loads of microwave oven transformers, so I chose the rewound MOT. Either way will work just fine for you. In the middle, we have the anodizing tank. This is simply a glass jar I purchased at the dollar store for storing spaghetti in, so it's quite tall, which is convenient. The wires that you see going up and down all around the inside of this container are made of lead solder. You need to use lead solder or lead wire of some sort for your negative connection in the anodizing. As you can see, the blue or negative wire from the rectifier runs to a clip lead which clips to these lead wires that are in the anodized bath. This brings us to the anodized bath itself. How do you make it up? Well, I went to the local auto parts store and I got a container of sulfuric acid used for filling car batteries when they're low. This acid, as purchased, is a little too strong for the anodize. So what I did was I filled my anodized tank about 4/5 full with distilled water, which I bought a gallon of at the local grocery store. Then acid, the acid that I bought from the auto supply place, is gently and slowly added to bring the level right up to within an inch of the top of my anodized tank like you see it. We now have a much safer dilute sulfuric acid that is not too strong now for the anodized process. The sulfuric acid, when dilute, won't dissolve the aluminum, but will allow the electric current to flow that makes the anodize take place. We then have a little DMM visible. I use this for two reasons. First, I use it as an ohm meter to verify that the wire or other connector I have on my part to be anodized is actually making a good electrical contact to the part. After all, we want to anodize the part, not just the aluminum wire or aluminum piece that's used to make contact with it. Now you can see I also have a cylinder with some blue fluid in it. This is simply degreaser, again from the grocery store, mixed with water. You do not want any fingerprints, any grease smudges, or any dirt of any kind on the workpiece that you're going to anodize, because all of these things will stop an anodize from forming. You could wind up with a fingerprint or a smudge permanently anodized into your part. We can see that I have a couple of parts. I have a battery tube and a threaded end cap ready to be anodized. These parts have been finished on the lathe. They've been polished. They're ready to go in the degreaser and then be anodized. I'm also showing at the extreme right a roll of aluminum MIG welding wire. This is useful for hooking up any oddly shaped part that you can't get an aluminum clip or clamp or some other way of solid contact to. Why do I keep saying aluminum wire or an aluminum piece to make contact? You can't put any other metal into the anodized bath, because the positive is going to be connected to that wire or metal piece that's connected to the part, and if we used copper wire or brass or steel wire, all of these things would react with the sulfuric acid and poison the anodize. So the part has to be connected by an aluminum wire, aluminum rod, or some form of aluminum connector. In order to begin anodizing, we need to check that our parts have valid electrical contact to their connection wires or pieces. We need to degrease the parts, and then, of course, suspend them in the anodizing bath with power connected so anodizing begins. Let's get started. The DMM is set to continuity so that it'll beep if I have contact. So, one lead on the part, the other on the wire. That one has contact. Let's check the other one. We have a beep, we have contact. So our parts are ready to be degreased. We'll start with the piece that's going to be a battery tube. So into the degreaser it goes. It doesn't take long. This part was thoroughly polished, rag wiped, everything to try and make it clean. And it is. Now we need it to hang midway in the bath. So we'll get a clamp on here that'll hold it at about the right height. In it goes. Sorry for walking in front of the camera. We'll connect positive power. The part is centered in the tank, and you'll see bubbles beginning to form on the negative lead wires. I'll try and zoom in right now and see if we can, yes, we can see the bubble formation. This means that anodizing has started, everything has contact, hopefully we'll get a good result. So I'm going to go ahead right now, zoom back out a little bit again, and in the second little cup I have second anodizing bath and negative lead electrode. I'm going to put the tail cap now into this little bath so we can anodize the tail cap at the same time. So I've made a little loop in its hanging wire so that it'll hang at the right height midway in the bath. A little support. Put it in, and I'll hook up a positive wire for it. Now, with both parts connected, it takes about an hour to build a good anodized layer with this setup. So, we'll come back in an hour's time and inspect the parts when they're ready to come out. Here are some sample parts of various kinds from previous anodizing runs. I'm just showing them as an example of what we want to achieve and what can be achieved with the simple process of anodizing. Right now we're about 15 minutes into the anodize. Notice that there's a lot of bubbling in this process, especially visible in the larger tank. A little bit of foaming. This is all natural, but I should point out the need for decent ventilation. I'm working in a well-ventilated area, and none of the small amount of fumes and gases that we can see being made by this process are able to build up. When you do this, make sure that you have decent ventilation. After all, any chemical fumes are just to be avoided. These aren't strong, but avoid them anyway. Use good ventilation. The bubbling will continue, of course, for the whole hour, unless something goes wrong, causing you to lose electrical contact. If the bubbling stops, look for a problem. Or you may, in an extreme circumstance, have to repolish and re-anodize your part if something goes wrong and you don't catch it right away. But this one, at the 15-minute point, seems to be going just fine. So we'll pick it up again at the 1 hour point when these two parts are ready to come out. When I'm anodizing, for acid safety, I keep a bucket with water and baking soda dissolved in it as a neutralizer for any acid spills. If I dribble some on the workbench or the floor, the very mild anodizing bath is easily neutralized by a little baking soda water. This water looks a little pinky red in the bucket because I put in a couple of drops of food coloring so that I know that's my baking soda water if I need it. Grab that bucket if there's a dribble or a spill or anything, and I can easily neutralize the acid. If you're going to do anodizing yourself, set yourself up with a bucket of water with a box of baking soda dissolved in it, and this will neutralize any acid that you need neutralized. When these two parts finish anodizing, I'm going to be dyeing them black today. So here's a shot of the dye I use. It's from Caswell Incorporated, available all over North America. They have a website. This is their black dye. I also have many other colors from Caswell. Their products work well. Now to dye, you can also use Sharpie markers. Either a black Sharpie or colored Sharpies will mark the anodized layer in aluminum. But for my main dyeing, I always use the Caswell products. Here's 1 liter of the Caswell black dye that's been mixed with distilled water at the recommended ratio. All I have to do to use this dye is warm it a little bit in my microwave. It doesn't want to be cold, but it doesn't want to be boiling either. Lukewarm, maybe 110 degrees Fahrenheit is a good temperature for the dye. I'm going to heat my dye up in the microwave now, because the anodize is nearly at the 1 hour point where I'm going to stop it, and we'll switch to dyeing our 2 pieces black. The black anodized dye has been warmed in the microwave, and I'm nearly ready to stop the anodize at the 1 hour point and dye the parts. So what I'll be doing is removing the parts from the anodized bath, where we can see them at the left. Then on the floor I have a bucket of plain water. I'm going to rinse the acid residue off the freshly anodized parts in this bucket of water. They'll go from there into the dye. The tall glass cylinder that I used for degreasing has been rinsed out, and I'm going to put enough black dye in it that the long battery tube can be dyed black. The little cut-off bottom of a water bottle I'm going to fill with the rest of the black dye. That's a big enough bath to dye the tailcap black. So that's what we'll be doing next. We're now at the 1 hour point, so we're going to dye our 2 items now that they should be anodized. So power's disconnected. Here's the tail cap. I'll rinse it in the bucket of water on the floor. And into the dye cup it goes. Now, we'll remove the battery tube. And again, we'll rinse it in plain water. Get the acid off. And it goes into the black dye bath. Now, as you can see, it doesn't take long for the dye to start working if we got a good anodize. And we seem to have gotten a good anodize here. So we'll let our parts sit in the dye. As you can see, the black is beginning to take on our parts. We want a nice, deep, rich black coating. It may take another 10 minutes or so for the dye to get there. So I'll stop for a moment and we'll pick up the dyeing process when I'm ready to pull the two pieces out of dye. The last step of the anodized process after dyeing is to boil the part, either in just boiling water if it's all you've got. I use a Caswell product, which I'll show here, anodizing sealant from Caswell. This is added to the boiling water bath, mixed as per the instructions, and it helps give the part a harder and better sealed and shinier surface. The dyeing is just about finished, so the next thing I'm going to do is take the parts out of the dye bath and put them into the boiling anodizing sealer bath. It only takes a few minutes of boiling, then the parts can be removed, rinsed, allowed to cool, inspected, and buffed. Well, the two parts are out of the dye, and I've quickly tossed them into the anodizing sealer bath to boil. In a couple of minutes, we'll have the results of our anodizing. Well, it's time to get our parts out of the anodizing sealer. Here comes the tail cap. It's of course boiling hot. And here comes the battery tube. Now I can turn the stove off, let it cool down. We'll let the parts cool down, and then we'll zoom in on them and examine them. Here's a look at the parts now that they've cooled. They're clearly dyed black, but as we can see, there isn't much of a shine on that battery tube yet. It looks all crusty and uneven. What we still need to do is dunk the parts in water and give them a good buffing with a rag. I'll do that, then I'll zoom in on them, and I'll show the finished result. Well, here are our two finished pieces. A beautiful shiny battery tube and a nice shiny black tail cap. These two parts came out perfectly. To do the whole anodize from start to finish, it took about an hour and a half. I started at 11 in the morning, and right now it's 12:30. So to anodize a part, or a bunch of parts, you're just going to need about an hour and a half in total to get the results I'm showing here. I hope this video was useful and helpful to you. Thanks for watching.